The paper I'll be presenting to you all today is called Analyzing Suspicious Medical Visit Claims from Individual Healthcare Service Providers Using K-Means Clustering. This was a joint study between myself and Dr. Rommel Carvalho and Carla Reis from the Master's Program in Applied Computing. The agenda for the presentation is, I would like to just present to you all the context of this research, the methodology that was used, business understanding, data understanding and preparation, shows the steps of the methodology, modeling and evaluation that was chosen for the study, deployment of our model, and finally conclusion and further works that are planned for this model. So as for the introduction, the context of this research is basically related to the healthcare field. I work for one of the largest healthcare insurance providers in Brazil. And the main issue that we face today in this market is the fact that we have rising healthcare costs. In Brazil, basically healthcare accounts for around 10% of our GDP. Some countries even more than that. USA, we know that's close to 20%. And a large part of these expenses are related to inconsistencies, waste, and abuse in general. Some estimate puts the total expenses related to healthcare and waste and abuse close to 15% of expenses, depending on the country. And the inconsistencies, waste, and abuse are usually related to overbilling, medically unnecessary procedures, and services that are just not provided. And the main difficulties that we face in detecting this kind of waste is in analyzing the claims data. And these are difficulties that you can find either in government institutions, healthcare institutions, or private. And usually related to the volume of records that you have to analyze, the different business rules for each type of procedure, and lack of behavioral analysis of provider claims. And so our objective in this research was to detect excessive billings from individual healthcare providers. Our focus was medical visits, medical visitations, and the specific scenario we were trying to detect was the impossible day, and I'll explain a little bit what that means later. Our methodology was based on the standard CRISP-DM data mining methodology, which has the business understanding steps, data understanding and preparation. Then you move on to your modeling, you evaluate your model, and you can go back and forth between these steps until you finally deploy your model and see what your results are. We use concepts of unsupervised anomaly detection. We didn't have a labeled data set that had abusive practices. We didn't know our behavior beforehand, so we used unsupervised detection. And the algorithm we used to cluster our data was K-means. And as for K-means, I just prepared just a quick primer of what it entails. K-means works by grouping objects by similarity in terms of distance. So if you have a sample data set there with 6 cases, and you start by assigning random initial centroids, which are your points of reference, you group together there on the third block, you group together the points closest to each centroid, then you calculate the average distance in each group, and then you recalculate, grouping again, the points closest to the new centroids. And you keep doing this until you have no significant change in your point of reference, your centroid. And of course, the biggest difficulty that you face in K-means, in any other clustering algorithm, is determining the number of clusters. This is very subjective. One way that you can find the optimal number of clusters is by using the sum of squared errors technique, where you basically just analyze the distance between each point in each cluster and its centroid. So if you have a smaller distance, that means that you have a better representation of your data, of your groups. So beginning with business understanding, as I said, the data that we analyzed came from one of the largest self-funded health insurance providers in Brazil. In 2014, the total expenses related to health costs was about 3 billion reais, works out to about 750 million euros. We have in our provider network 2 types of providers mainly. You have institutions, which are hospitals, clinics, laboratories, and individuals, which are just your individual doctors, your specialists, your therapists. And the problem we face in our company is that we lack automatic controls. We have checks to see how many how much, the quantity of service that each patient has in a single day. So if you try to have 100 medical consultational visits, the system catches that. What we do not have is a kind of control that sees how many patients each provider has seen per day. Why? Because institutions, usually you can say that a hospital, for example, can see upward to hundreds of patients a day. But a single individual doctor, he obviously will have some kind of limitation. And we also don't have a control to see provider behavior in relation to its peers in the same region. So we don't have any kind of behavioral analysis. So one possible kind of abuse that could be going on is services not rendered. So the impossible day scenario where a provider, a single individual provider, would claim to have serviced way more patients than it would be possible in a 24-hour period. So, moving on to our data understanding and preparation. The initial data extraction came from our institution's claims database, period from January to December 2013. Our filters were, of course, individual providers, medical visits, procedures related to medical visits only, and the claims related to our external authorization system. This is just a system that we have in place that checks the date and the exact time of each transaction, each claim that's submitted to our system. Our initial data set consisted of about 1 million records, 13,000 individual providers, and a total value of about 16 million euros or 65 million reais. The initial variables we chose were provider ID and patient ID, the claim number, each claim number, service date, and for each date the quantity paid and the amount paid for each visitation. With these variables, these three variables, service date, paid quantity, and paid amount, we calculated for each provider on each date how much was paid and the value, of course. And with that new subset of data, we did a little interval analysis. We saw, okay, so for quantity of visits per day, 99% of records are related to 0 to 10 visits per day, which is reasonable. And less than 1% of records were related to more than 10 visits per day, with a maximum of 93 visits per day. So the problem we face here, okay, what is a reasonable amount of visits, medical visits per day per provider? So then what we had to do is go to our medical experts, our doctors in our medical area, and ask what would be the maximum number of visits per day. And a very rough estimate was that, okay, each visitation would last about 15 minutes, and the provider would work 8 hours, non-stop, basically. This is a very rough estimate. And if you calculate that, you come to 32 visits per day, and that would be your limit. So, and then we check, okay, so how many providers of that in this data set went over that limit? And we saw that about 18 providers, with an amount paid close to 600,000 reais, at some point they went over that limit. And this is just an example of that external authorization system. We saw here that one of the providers with the highest quantity per day, he didn't take 15 minutes per visit. He took about 30 seconds. So he just submitted every 20, 30 seconds a new claim. So that's way above what you would see normally. So something was wrong. But then you have problems working like that. That first model gave us a lot of problems. First, because of your false positives. Maybe a provider went over that limit on a single day per month. So he just basically did what? He accumulated all of his claims, and on the last day of the month, he just submitted everything on the same date. That's wrong, but it's not necessarily abusive because the services were rendered. But it's still a problem. You wouldn't really analyze that. A larger problem would be your false negatives. And the false negatives is that if you set a 32 visit per day limit, anything below that you're not going to catch. You're going to have to keep lowering your limit until you catch those. And the problem is how long do you go on lowering your limit? And what is the real limit? If you could submit very excessive quantities, and if it's below your limit, you're not going to catch it. So then we had to improve this model, obviously. And we decided to focus on three attributes. So you had your alert, which we already had, which was the quantity of distinct visits in one day. Our volume, so how many patients did that provider see in a single month? and on how many days did he submit claims for. So you had three variables now. Besides the alert, you had your volume and your frequency. So then we have to go back to the data manipulation stage, or data preparation. We had those initial variables: provider ID, patient ID, claim number, service date, and the payment amount and quantity. And with these variables, we made new variables, which was the quantity of day, we already had it. And we calculated for each provider and day the quantities of patients that provider saw in that month. So January, he saw 15. And the number of service dates per month. So out of 30 days or 31 days, how many days did he have medical visits? So going back to that distribution we had, we calculated using means and standard deviation what would be a reasonable amount. So we used the mean of that the initial data set plus the 6 sigma limit, the 6 times standard deviation, to see that most of the records were below 10.6 visits per day. So we used this as a threshold to build a new smaller subset with about 2,000 records, which would be a lot easier to work with when you're working with clustering, because it's very, very intensive. So in these 2,000 records, you had about maybe less than 1% of the data, but would be the data that would have the most visits, the ones that would be more likely to be abusive. These are just the initial visualization with the application of the k-means algorithm. We saw 4 clusters, and we determined the number of clusters by the sum of squared errors technique. And we saw that cluster 3 visually was able to more or less capture all of the outliers when you compare pairwise each of the 3 variables. So if you compare quantity of day with days on month, and quantity on day with quantity of patients per month, you see that cluster 3 had more or less successful in capturing most of the outliers. This is one way to validate it, but of course you want to look at the raw data. So for each cluster, 4 clusters, you have the number of records in each one of them. We saw that cluster 3 already had those 18 initial suspects. That cluster was able to group together all of those initial suspects, which were above 32 per day, and also some almost 50 other entities, other providers, that also had excessive quantities, but were below that initial threshold. So with this result, we calculated for each cluster and for each variable the means and standard deviation values to see the differences between each cluster and each variable. And we saw, of course, that in cluster 3, the means value for the quantity of day was way higher than the other clusters. And cluster 4, what we saw later was that days on month and quantity of patients a month were also higher than the other ones, even higher than cluster 3. So we had now for each cluster and each variable the means and standard deviation. With this information, we were able to build a simulated distribution to see the likelihood, the probability that each of the variables in cluster 3, which was the most interesting, the probability that the variables would be found in the other clusters. So then we saw there's basically no chance that cluster 3 quantity of day variable, for example, with a means of 30.2, they would not be found in the other clusters. So it would actually be more distinct, and you would probably try to focus on this cluster, the entities in this cluster for evaluation. And then finally we come to the deployment stage of our model. As for investigative purposes, you would try to focus, of course, on the clusters with the highest chance of excessive billings. That would be, in this case, cluster 3 and 4. These new providers that we saw here, we would need, as of the writing of the paper, we didn't have time to analyze them, but they would be prioritized for further investigation. And the final results were these. Out of 18 initial providers, you had your data set with 13,000, you had 18 suspects. 11 of them were confirmed suspects, so they did not have a plausible explanation for that amount of billings that they presented to us. The amounts were about 300,000 reais involved. And for these confirmed suspects, what we would try to do is just monitor their billings for another period and see if their behavior changes after they found out that they were under investigation. And you would probably try to, for the worst cases, terminate their contracts. As far as advantages of the model and future works, the main advantage is that you no longer have to set a limit, a specific limit, 32 per day or 30 per day. The model itself tells you which ones are the outliers, so those are the ones you have to focus on. And this model can be applied to other types of procedures, and it can be tweaked if you want to try to eliminate other false positives. For medical visits, the investigation is not very time intensive, so false positives are not that much of a problem to us, but for other procedures it might be. These entities that we can be classified now as true positives, their behavior can be used as a starting point for investigation in other data sets or other periods. And we can, as I said, you can expand this model for other types of procedures. This is just medical visitations, but you can have for acupuncture, for physical therapy, speech therapy, many other types of procedures that you can apply this to and have similar results. And one of our next papers would be analyzing this, the application of this in another type of procedure, which was psychotherapy. Oh, thank you very much for your attention. This is my contact information. If you have any questions, I'll be glad to answer them.
Thank you very much.